Hello, and welcome to Training with Trisonius. I am Trisonius. Today, we're going to focus on conditional statements. So it's with conditional statements that we implement control logic in C#. This allows us to simulate computers making decisions. So let's focus on what we're going to learn today. So we're going to learn about comparison and logical operators. We're going to learn about the if statement, which is one of the basic logical constructs to simulate a decision. We'll learn about the if-else statement. We'll learn about nested if statements, and we will learn about the switch statement. So today's lesson is all focused on conditional logic, or simulating how an application or program can make decisions based on data. So let's jump right in. So let's talk about comparison operators. Comparison operators are used to compare two or more values and produce a true or false answer based on the context of the comparison. So if we want to determine if two values are equal with one another, we would take two values, and in between those values, place an equals sign. Now you may ask, why do we use double equals to determine whether or not something is equal? Well, remember, the single equal sign is an assignment operator. So it allows us to assign what's on the right-hand side of the equal sign to what's on the left-hand side of the equal sign. But a double equal sign, it is an operator that allows us to compare. It's a comparison operator, and it looks to see if each value on either side of the double equal sign is equal. If they are equal, it will return a value of true. And if we do a comparison and they're not equal, obviously it'll return a value of false. So sometimes we want to determine if something is not equal. So we can determine if something's not equal by using an exclamation mark, or as some people refer to as a bang, and then an equal. And so if something's not equal, the condition will return true. But if it is equal, it'll return false. Because here we're checking to see if the values are not equal. I'm sure you remember from basic arithmetic that the greater than sign, and that's exactly the same here with C# and computer programming. If the value on the left of the greater than sign is greater than the value on the right of the greater than sign, then the expression will evaluate to true. However, if the value that on the left-hand side is less than the value on the right-hand side of the greater than sign, the expression will return false. So sometimes we want to make sure to see if it's greater than or equal to. And so you can see that we use the greater than sign, and then immediately following that, the equal sign. And this is the C# notation for greater than or equal. And less than is the standard numeric or arithmetic less than operator. And then we have the less than or equals. So an example of this would be listed below. So you see we have a Boolean data type that's been declared as a variable by the name of result. And inside of that, we're going to make that equal to 5 is less than or equal to 6. Now, is 5 less than or equal to 6? Well, 5 is less than or equal to 6. So that expression would evaluate to true. So then when we did a console.writeLine and we wrote the result, we wrote result to the screen, it's going to display a value of true because that expression evaluated to true. It'll make more sense as we move forward. So in addition to comparison operators, there's also logical operators. So in C#, logical operators are used to perform the logical operation between two operands or expressions, like and, or, and not, based on requirements. So you may want to evaluate more than one expression. For instance, maybe your computer is interested in targeting a segment of a segment of the population because you're writing an application that's going to do marketing for a local business. And so you may write an application that says, hey, if their address is within 20 miles, right, and they've shopped in this store before, then we could target them. We could perform some action, send them a newsletter or send them a gift certificate or something of that nature. But logical operators allow you to string together multiple expressions for evaluation at one time. So logical operators will always work with Boolean expressions. So they're always going to return true or false, just like we talked about with the comparison operators. So the operands in logical operators must always contain only Boolean values. Otherwise, logical operators will throw an error. So what that means is that you're always going to look for the result to be true or false. So there's a logical not, just like in the previous screen when we were looking at comparison operators, we saw not equal. And so here the logical operator not is a bang or an exclamation mark. Now if you want to check to see if two conditions both evaluate to true, or two expressions I should say both evaluate to true, then you would use an and in between them. And the and is represented as two ampersands. That's the notation in C#. Now if you had two expressions and you only cared if one of them, one or the other was true, well then you would use an or operator. Because either this one needs to be true or the next one needs to be true. And the notation in C# for an or logical operator is a double pipe. We'll see some examples of this as we get into coding. So most often these conditional operators and logical operators are used with conditional statements. So the most simple conditional statement is the if statement. And what it does is it allows you to test for a condition, and then it allows for branching to different parts of the code based on the result coming back from testing that condition. So the simplest form of an if statement is shown right here on the screen. You can see the gray box in the center of your screen, and you see the form of the code. And so you'll see if, and then in parentheses is a condition, and if statements represent a block. And so you see your opening bracket and your closing bracket, and then your statements go in between. Your statements are the code that is to be executed when the if condition evaluates to true. So here's how it works. So logically, the workflow is we come in and we evaluate the condition. If this condition evaluates to true, then your statements are executed. If the condition evaluates to false, well then the statements are skipped. I hope you're not still confused. Here, let's give an example of this to show a little bit more in detail about what we're talking about. So the below is an example of a simple if statement. Pay particular attention to the different elements that we've learned so far. So up at the very top, you can see that we are declaring and initializing two variables. So we're declaring a variable of type integer that we have named strength, and we're assigning an initial value to it of 15. Then we are declaring another variable of type int, which we are calling dexterity, and we are assigning to it an initial value of 12. When you assign a default value or the initial value to a variable, it's known as initialization. Okay, so now some people will say only when you assign a value at the same time that the variable is declared, is it initialization. Yeah, that may be true, and I may have misspoke slightly. Either way, here in this case, we are declaring the variable and assigning a value, so we are initializing that variable. Okay, now once we have our two variables, each containing values, a strength of 15 and a dexterity of 12, you can see that we go down a couple of lines and we come to our first if statement. This if statement is a conditional statement, and it has an expression in between the parentheses. There's a conditional expression, and it gets evaluated to either true or false. In this case, we're checking to see if strength is greater than 10. Now we happen to know that strength was given a value of 15. So strength is greater than 10. So this conditional statement or expression here should evaluate to true. Since it evaluates to true, we go inside of the brackets of the if statement, and the console.writeLine, this character is strong, would be printed to the screen. Move down a couple of lines and we come to yet again another if statement. But this time the expression is different. We're now going to evaluate an expression to determine if dexterity is greater than 10. Now we gave our dexterity a value of 12. So dexterity is greater than 10, and therefore this condition will evaluate to true. Since it evaluates to true, it also will execute the statements that exist between the brackets of the if statement. It'll go into the block of code and execute those statements associated with the if statement. So we would see the sentence, "This character is fast," appear in the console window. Now, if we scoot down a little bit farther, we're going to get to we're going to begin to see not just the comparison operators, like the greater than that we've been using, but we'll use some logical operators here as well. So in this if statement, we've got one expression that we need to evaluate, and it is determining if dexterity is greater than 10. Well, we know dexterity is greater than 10 because it's a 12. So we know the computer is going to evaluate that to true. But what we want is this logical operator here is an AND. So what it means is that both of these expressions need to evaluate to true. So the one on the left and the one on the right need to be true, and that's what the logical AND operator does. If this had been a logical OR operator, well then either expression 1 or expression 2 could have been true. But since we're using an AND logical operator, they both need to be true. So the first expression is dexterity greater than 10, and so it's going to evaluate as true. And strength greater than 10, it's also going to evaluate as true. Because both expressions evaluated as true, the entire condition, the compound expression, will evaluate as true. And so since the compound expression will evaluate as true, then the if statement will allow access into its block of statements, and we would see "This character is fast and strong" appear on our console window. Now, if we were to go back and we were to decrease our dexterity value to, let's say, an 8, we would still see that the first if statement, where we're evaluating strength, would still resolve to true, and we would see this character is strong. However, the second conditional expression, dexterity is greater than 10, would return false, because dexterity wouldn't be greater than 10, because we would have set it to 8. And so it would skip that line of code, that statement where it says this character is fast, and never print that to the screen. And then when we got to our compound if statement, we would it would also skip and not say this character is fast and strong, because expression 1, dexterity is greater than 10, would return false. And because we're using a logical and, they both would need to be true. Okay, I hope that makes more sense. And we'll see some examples of this in more detail as we get to our coding example. So that was the if statement. Now, more commonly in code, you will see an if-else statement used. Now, this construct is a little bit more complex, but it's a more useful conditional statement. So what happens is it executes one branch of code if the condition is true, and another branch if the condition is false. See, in our previous example, if it evaluated the true, it executed the statement. If it evaluated the false, it skipped the statement. But in this case, we've got two branches. And so the simplest form of an if-else statement is shown below. So in the middle of your screen, you see a gray box, and you can see the if statement with the open parenthesis and expression in between, and then your open bracket and close bracket, and then your statement. So that first part is exactly like a normal if statement. However, if we put the else keyword there and then create another block of code, we can add another statement. So the if else says, okay, I'm going to evaluate the expression in the if statement. If that expression evaluates to true, then I'll jump inside of the block of code associated with the if statement and execute that statement. However, if that expression evaluates to false, well, then I'll jump into the else block and execute statement 2 instead. So I hope that makes sense. It's very similar to the first. It's just that now we're saying, hey, if this expression is true, then execute statement 1. Else, execute statement 2. Okay. Let's go ahead and move forward. And again, we'll see an example of this as well. So let's say we declare a variable, again, of type integer. We name it strength, and we assign an initial value of it to 10. And then our if statement has an expression where we're going to evaluate this expression. And this expression is strength is greater than 12. Well, is strength greater than 12? No, it's not. The computer is going to look at that expression and say, oh, this expression is false. It's not true, because strength's only a 10, so it's not greater than 12. So when the computer evaluates, as part of this program, the fact that strength is, that this particular statement or expression is false, it's going to jump down to the else block, and you would see the character lacks strength printed on the console window. Only if that first expression in the if, with the if inside the if parentheses evaluated to true, would you see the character is strong. Okay. Goodness, I got a little tongue-tied there. Okay. Now, it can get a little bit more complex than what we've looked at, but it's not hard. So the if and if-else statements can be nested. So they can be used inside another if or else statement. So every else corresponds to the closest preceding if that has not already been paired with an else. So here, there's an if statement. My cursor is pointing to it. and it has an expression. If this expression evaluates to true, then we're going to jump inside of this first block of code associated with the if statement. In here is another if. If this expression evaluates to true, we'll execute this statement. However, if this expression evaluates to false, we'll jump down to the else and execute this statement. This else down here is paired with this if, because this else is paired with this if. And so every else corresponds to the closest preceding if that's not already been paired with an else. So this if has already been paired with this else, so this else is paired with this if. Now, as a matter of practice, we should use indentation just like we have here, so that you can visually see that this else is aligned with this if, and this else is aligned with this if. And so it's really important to write clean code and use indentation to help other programmers that come behind you, or even yourself. When you write code and then you come back to it a couple of weeks later, you may not remember everything that you wrote. And so making sure that you use good programming practices will minimize the amount of time it takes to refamiliarize yourself with that code. Okay, let's go ahead and move forward. So, just like I talked about, there are some best practices. So we always want to use blocks. So use these brackets to signify a block of code. Because it avoids ambiguity. I mean, even if there's only a single statement, it's a good idea to go ahead and surround it with brackets in a block of code. Avoid using more than 3 levels of nested if statements if possible, because that can become pretty confusing at that level. So if you can avoid using more than 3, that's a best practice. Put the case that you expect to process most frequently at the top, and then write the unusual cases later. And then finally, arrange the code to make it more readable, meaning make sure that you indent your code correctly. So in this code example here, we see if first is equal to second. So if first and second are equal to one another, then it's going to jump in here and it's going to execute this statement, and it's simply going to print to the screen these two numbers are equal. So that's great. Now this assumes we have a variable called first and we have a variable named second. Now if first was not equal to second and this expression evaluated to false, it would jump down into the else. Then it would check to see, okay, is first greater than second? So if first is greater than second and that evaluated to true, then we would write to the screen the first number is bigger. Otherwise, the second number is bigger. And so this is an example of how you would use a nested if inside of an if-else block. Okay, let's go ahead and move on. So sometimes you may have multiple if-else blocks that run together. And so sometimes we may need to use another if construction within an else block. So what we can do is we can use what's known as an else if. So in this particular example here, we can see that there is an integer declared as ch, and in it we put a single character x. And then we can check to see if ch is equal to uppercase A or ch is equal to lowercase a. Well, we know that ch is not equal to uppercase A and ch is not equal to lowercase a. We know it's equal to uppercase X because we just declared it. So when these lines of code get executed, and when this conditional statement, when this conditional expression, this compound expression right here gets evaluated, it's going to evaluate to false. So when that evaluates to false, it's going to skip this if statement. Then we come down here to an else if. So we're going to skip this if statement. We're going to jump down here, and it's going to check to see if this evaluates to true. If this expression, this compound expression, evaluates to true. In this case, it will not evaluate to true because, again, ch is equal to x, not an uppercase or lowercase e. So it would jump down to the next else if, and it would look to see if that expression were true. It'll go through every single else if expression until it finds a match. If it finds a match, it will bounce into that block of code and execute those statements. However, if it doesn't find a match, another way of putting that is if the expressions never evaluate to true, then it will, and you've got to the last else if, then it will roll to the else block of code and execute that. Okay. The last conditional construct that I'm going to talk to you guys about today is the switch case statement. So the switch case, it evaluates a switch expression and executes a matching case statement if one is found. So if a matching case statement is not found, the default case is executed. If a default case is not present, the switch statement skips all cases and executes nothing. So the standard form for a switch construct is shown below. So we can see this right here in the gray box. So we have the word switch, this is a keyword, and then in parentheses we have an expression. And so we then have a block of code, a block signified by these brackets associated with our switch statement. And inside of that particular code block, we put our cases. We literally type in the word case and then a space, and then we type in what's called a constant label. A case label. We type in a value here that's a constant, and then a colon. Then we put one line or more of statements. This is the code to be executed, and then a break. So when we have a switch statement, we have an expression. What the switch statement does, or what the switch construct does, is it looks for a matching case. So does this particular constant or label equal the expression? If it does, then it'll jump into that particular case, execute the statements, and then call break. The break keyword. Now when the break keyword is encountered, it will break out of the entire switch construct. So it bounces all the way down and skips all other cases. So the one thing to know about a switch expression is that once a break is encountered, you exit the switch statement. Now, it's good practice to put a case default at the bottom of your list of cases with a default statement that you would like to have executed in the event that no match is found. So let's walk through this one more time and how a switch case works. The expression is evaluated. If a matching case constant is equal to the expression, the statement corresponding to the case is executed. If no matching case constant is found, if there is a default case, it is executed. Otherwise, control is transferred to the end point of the switch construct, which would be this bracket, and no statements are executed. And so you must find an exact match. You cannot use ranges in your case. It must be an exact match. Otherwise, it will fall to the default case if one exists. And again, best practice is to make sure you have a default case in place. Okay, so I'll give you an example of this, but first a couple of rules. So the data type string and enumeration, which you haven't learned about yet, but you will, and other integral types such as int, double, byte, all the different data types we've talked about, they can be used as a switch expression. The value null is allowed as a valid case constant as well. The keyword break will exit the case statement. Multiple case statements that pertain to the same statement, multiple case constants that pertain to the same statement are allowed. And you can use multiple case constants to execute the same statement. So here's an example. So here we have our switch statement, and in parentheses we have animal. Now let's just assume that animal is a variable of type string, and we placed the name of an animal or type of an animal in there as a string. So let's say that we placed crocodile. Well, we'll use that. Now we placed dog as the value. We'll use crocodile in a second. What'll happen is it'll evaluate this statement and say, oh, animal is dog. It will then look at each of the cases until it finds dog. In this particular instance, dog would be found here. So we would write, it would come in and it would execute the statement and write the word mammal to your console screen, and then it would break, meaning it would exit out of the switch construct completely. Now, you can have cases that fall through. So in this case here, let's say that the animal, the value that we put into the variable animal was tortoise. So as it entered the switch statement, we would say tortoise. It would look and evaluate this is tortoise, and then it would look for a case. And here it would say, oh, dog, nope, that's not it. So let's skip. Crocodile, nope, that's not it. Let's skip. Tortoise, okay, I'm going to go in here. Well, when you go in here, there's no statement to execute. So what it does is it falls through to snake and then gets to the statement, which is console.writeLine. So we would see reptile show up on the screen, and then a break statement is found, which would prevent it from ever executing default because it would break out of the switch statement completely. So instead of repeating this particular statement for crocodile and tortoise, these three cases, it allowed for fall through. Okay, so I hope that makes sense. We're going to get to the code here in just a second, and so it'll definitely make more sense as we continue on with the application that we've been writing. Okay, let's go ahead and open up Visual Studio. We're going to go back to the Console Lesson 4 application that we have been building upon. So let's go ahead and open that up. And here you can see that we have all of our variable declarations. And then we've got our create character and display character methods. And so, okay, here we are. So if I go ahead and run this application, it's going to be where we left off at the end of the last lesson. So let me go ahead and start without debugging just to show you what the results are. And we get a prompt asking for the character's name. So I'm going to type in Trisonius. And for profession, I'm going to type in programmer. And then we get name Trisonius, profession programmer, age 27, and we get our stats just like we were talking about. So that's fantastic. I think that's wonderful. Now, I believe that I had asked you guys to implement a eye color and hair color method as well, if I'm not mistaken. So, for those of you who did not have a chance to do that, we will do that together very quickly. So, let's come up here and let's declare static string um, eye color and static string hair color. And let's come down here and let's go ahead and add two methods. Static void get eye color. And then let's go ahead and build out the empty um, the empty block for the other method. Static void get hair color. Okay. So here, let's go ahead and type in console.write. Please enter your eye color. Okay, and then we will take and use our variable eye color and assign to that exactly what they type in. They type in the console as a response to that question. Now let's come down here and do the exact same thing. Console.write. Please enter your, oops, I can't spell, your hair color. And hair color will be assigned what they type in as a response to this as well. All right. Now that we have these two new methods, we have a create character. And here we've got get name, clear console, get profession, clear console. And I'm going to add get eye color, clear console, and get hair color, clear console. Alrighty. And then here where we display our name and profession, I'm going to console.write, open parenthesis, eye color, and then console.write line, and we want to print out what's in our variable for eye color. And then console.write hair color. And then the same thing, let's console.write line hair color. Now, you notice how simple it was for me to come in and know exactly where to write that code. So I knew exactly, because we have a create character method, so I knew exactly where to put it. We have a display character, so I knew exactly where to put it. And it's because I wrote these in their own methods, and we already had a clear method, so we're in good shape. Okay, so let's go ahead and save this and take a quick look to make sure that it does what we think it's supposed to do. So it should ask us again for our name, which it does. And so Trisonius, profession, programmer, eye color, hazel, hair color, silver. All right, and there we go. Now we've added eye color and hair color just like we talked about doing. All right, so that brings us up to speed, and that's what we were asked to do at the end of the last lesson. Now today, we're going to add another important factor. So let's add another method, and this one's going to be called getRace. And because this is a fantasy game, our race can be our races can be human, elf, dwarf, half-elf, gnome, troll, whatever we want it to be. So let's go ahead and type in console.write, and we're going to ask, please enter your character's race. All right. And then, oh, you know what? We have to go declare a variable, put that into, don't we? So let's come up here and below, I'm going to do it below profession. Below profession, static string race. All right, sorry about that. I hate to bounce around like that, but now let's come back down here to our method. So now we have a race equals console.readLine. So whatever they type in response to that particular prompt will be the race. Okay, so that's kind of cool. So let's go ahead and display their race as well. So that's cool. So let's come up here to display character, and I'm going to put it below profession. So console.write race. You know what? We're going to put we want that to line up, don't we? There we go. And then console.writeLine, and we want to write out whatever we have in our race variable. Okay. So now, that's great. Now we need to call our getRace. So let's do that right after we ask for the profession. So getRace, and then our clear console method. Okay. So there we go. We've done that. We've got the race. And then I'm going to create a new method, and we're going to call this method static void assign racial modifiers. Because based on what race you are, you may get some bonuses. For instance, here's what we're going to do. We're going to put a quick if statement in here. Okay, so let's put if race equals human, but what if they spell it with a capital H, you know? So we'll do that too. Or race equals human. So we'll just check for both of those right now. There's a better way to do this, but just right now we'll do it that way. All right, and we'll put our brackets. Now, I think that humans should get a bonus to their strength. So what I'm going to do is I'm just going to take strength and make it equal to strength plus 1. Now, what that does is that will increase our strength by 1, because what we're telling the program to do is to take 1 and add it to the existing strength value and then assign that to the memory location. So take 1, add that to the existing strength value in the memory location, and then assign this value to the memory location used for strength. Sounds kind of weird, but in this way, we are adding 1 to strength. Now, there's a shortcut for this, and it's a shorthand operator. And so we could just simply put strength plus equals 1. And that, plus equals 1, and that will do the same thing. That's shorthand for strength equals strength plus 1. That's a whole lot easier to do. So I'm going to put strength plus equals 1 here. But if you want to put strength equals strength plus 1, go right ahead. They're equivalent. This is just a shorthand way of doing that. Now, if race equals elf, or race equals elf, then we could do something else. And so let's put that, I'm going to put that their dexterity plus equals 1. Okay, and then if their race equals dwarf, I would like to increase their constitution and their strength by 1. So I'm going to put strength plus equals 1 and constitution plus equals 1. And just to make sure that you know that this is working, let's make that a 10. That way it'll be a bigger value, because we know the base constitution is 15. Okay. So that's great. So what we want to do is, after assign stats, we want to make sure that we call assign racial modifiers. So we come up here, and after assign stats, let's call assign racial modifiers. Okay. And so that means in create character, and create character is being called before we display our character, so we should see those adjustments show up based upon our race. And so here we're making the computer make some decisions using these logical constructs that we just learned about. And so we're using the OR logical operator, which means that if they type in this or this, then this will evaluate to true, and this statement will get executed. Okay, so let's just go play with this real fast and see if that worked. So start without debugging. Character's name is Trisonius. Profession, well, I'll be a warrior this time. My race, you know what? Just because I want to show you that it worked, we're going to be a dwarf with a capital D. Eye color is going to be hazel. Hair color is going to be red. All right. And you can see that Trisonius is a warrior dwarf. Hazel eyes, red hair, age 27. Strength's an 18, and we know our base strength was a 17, so it added 1. But more importantly, the constitution is 25, as you can see right here. So it definitely did add that plus 10. Now, just to make sure that we're not adding the same value to everything, let's run this again. And this time, we will be an elf. How about that? Trisonius, I will be a wizard, elf. Eye color will be red. hair color will be silver. Look, there we go. So that's great. And our dexterity went up by 1 because by default it's a 12. But you can see our constitution is back to 15. The plus 10 did not get added. And so you can see the computer is making decisions based off of data for us. And that's fantastic. Now there's some flaws in this. Let me give you an example. If I come here and I were to type in name, Trisonius, profession, warrior, race, dwarf. Yeah, we'll just make it all caps. Eye color, green, hair color, silver. All right, you notice I didn't get my plus 10 to Constitution. And that's because we're only checking to see if the first character is uppercase or lowercase, because C# is a case-sensitive language. And so capital DWARF is different than capital D lowercase WARF as far as C# is concerned. So how do we fix that? So there's some things that we can do. One of the things that we can do is we can temporarily take race, because it's a string, we can convert it. See, because it's race, it's a string, it has some built-in methods for us. And one of those methods is to temporarily convert the values to lowercase. So I could type in here, if race dot to lower, and let's just do that again so you can see that what it says. To lower returns a copy of this string converted to lowercase. Well, excellent. I don't want to convert the original. I just want to convert a copy to lowercase. So that's perfect. So equals human. So now I only have to check for lowercase, because it's going to take a copy of it and convert it to lowercase. The same thing's true here. I can do this to lower, and I don't need to worry about anything else. And finally, the same thing here. Because since we're converting race to lowercase, now we only need to see if it's equal to lowercase. These others don't really matter. And I'm going to make dexterity plus 10 for elf so that we can see a little better there as well. So now let's go back and rerun the same example we just did. So Trisonius, warrior, race, all capital dwarf, eye color, green, hair color, silver. All right. So there we go. It's still all capital dwarf is what's in memory. But we temporarily converted it to lowercase to see if it was lowercase dwarf, and it was. So we got our plus 10. I hope that makes sense. Now there's another issue that we have, and that is that we don't really have any defaults. So let me give you an example. Let's run this one more time. Name, Trisonius, profession, warrior, race, troll, eye color, orange, hair color, blue. All right. You notice we just got the default stats. Trolls didn't get anything at all special. And that may not be what we want. We may want the ability to have a default. Well, in order to have a default, we need to chain these if statements together. So, right now, it checks each one of these, which is good. But I only want it to be able to execute one of these, and then if it can't find any, if it doesn't match any of these, to go to an else. So we learned about this in our lesson today. So what we're going to do is we're going to turn this into an else if. So if raised to lower equals human, do this. Else if oops, I don't want to do that. Else if raised to lower equals elf, then do this. Else if dwarf, do this. Now, and I don't like doing it that way, sorry. I'm going to bounce that right down there. That way you see the end, beginning and end of the block. You can see the beginning and end of the block, and you can see the beginning and end of the block. And then I'm going to put an else right here. And on this one, we're going to make strength plus equal to 10. All right. So what's going to happen is it's going to look to see if there's a match for human. If there is, it'll execute the statement. Because this is our condition, or our this is the condition that's evaluating to either true or false. And so if this evaluates to false, it goes here and evaluates this. And then if this evaluates to false, it moves down here and evaluates this. And if this evaluates to false, then it jumps to else. So we're going to go ahead and run this again. And because we don't have troll, it should jump to the else. And the strength should go up by 10. So let's just see if that really works. So again, name, Trisonius, profession, warrior, race, troll, eye color. This time I'll make the eye color gray and the hair color light brown. All right. And there we go. And of course you can see the strength is 27. So it did add 10 to our base 17 strength. So it worked exactly like it should have. So these are examples of if statements and if constructs. And so you're able to evaluate a statement like we've got, well, not a statement, but you're able to evaluate a condition, an expression. And so this is our expression. And if this expression is true, then the statement within the block is executed. And this could be more than one statement. We could decide that we wanted to add something to Constitution. So maybe we want to add 2 to Constitution because humans are pretty resilient. But maybe you want to put minus equals 1 for dexterity, if I can spell dexterity. And so minus equals is shortcut for taking 1 away. And that will remove 1 from the existing value. And so this is the way that you use if statements in an application. We will be using if statements a lot more as we move forward. If constructs as a whole, and we're going to be using the switch as well. So inside of an if statement, you can actually have a switch statement. Inside of a switch case, you can have an if statement. And inside of an if statement, you can have another if statement, which is a nested if. And so, for instance, right here, we could put another if and check to see if age is less than 30, then I want to add, we'll add it to dexterity, no, Constitution. Constitution, we're going to add 2 more. And so if their age is less than 30, it'll be a total of 4 that they get. But if their age is not less than 30, then they're only going to get the +2. Okay? So there's an example of an if within an if. And so let's go ahead and go run that. Debug, start without debugging. And we'll just be a human, and we'll give that a shot. So Trisonius, warrior, race, human, eye color, brown, hair color, brown. And for our strength, we have an 18. But for our constitution, which is a base of 15, we got +4. And that's because our age is below 30. So here's something I really want you to pay attention to. Let's go up and change this individual's, oops, let's go to the assign, sorry. Let's go to the assign stats. Let's change their age to 30. Do they still get the +4? I don't know. Let's do the exact same thing we just did. So Trisonius, warrior, race, human, eye color, brown, hair color, brown. Their age is 30, but they only got +2. Is that right? Is that really what we wanted? Because they're 30 years old. It says that they're less than 30. Oh, you know what? Actually, it did exactly what we told it to do. Because the age is 30, then their age is not less than 30. It would have to be 29 to be less than 30. 30 is equal to 30. So if we want to include 30 in our if statement or in our expression, the evaluation of our expression, then we need to make this less than or equal to 30. Now, if we make it less than or equal to 30 and we run it again, we should get the +4. Trisonius, warrior, human, brown, brown. And we did get the +40 this time because our comparison operator went from less than 30 to less than or equal to 30. And so now it got included, and therefore our age evaluated to true against that particular condition. All right. Well, I hope that this helps. I hope that this makes sense to you. And as usual, we'll have a review and then a homework assignment. Okay, well, I'll get to the review here just really quickly, but thanks for walking through this with me. We'll jump back into Visual Studio with our next class. Okay, now that we've finished our code, let's look at our lesson review. So here's what we've learned. Computer programs simulate decision making through the implementation of control logic using conditional constructs. And so those constructs that we learned about today are essentially if and switch statements. The most commonly used conditional construct is the if statement, which uses comparison and logical operators to evaluate a conditional expression to determine if a statement should be executed. If statements come in multiple forms. We learned about this. So we learned about the simple if block, we learned about the if-else block, and we learned about the if-else block. And then we also learned about the nested if statements, which combine some or all of the previously mentioned if constructs. So in addition to the if statement, another conditional construct comes in the form of the switch case construct. Now, the primary difference between an if block and a switch block is an if block can evaluate multiple expressions using logical operators to execute statements, while a switch block can only evaluate a single expression and execute a single statement based on matching case constant or by falling to the default case. All right, so good job. Hopefully you followed along with this. We will be using conditional constructs throughout the rest of the course. So if you are struggling in any way, make sure to drop me a line below the video and I'll help answer that. Or just hang on, because I'm sure we're going to touch these topics multiple times as we move forward. So as usual, I have an assignment to make sure that you understand what it is that we worked on. So here's what I'd like for you to do. In addition to the code that we already wrote together as part of this particular lesson, I'd like for you to add a new method to your program and name it Generate Description. Now this will be a void, so it'll be a static void generate description. Within the new method, implement a series of if constructs or switch constructs. So I don't care if you use if or switch, it doesn't matter. That will evaluate all numeric statistics and construct a description of the character. Now this description should include a mention of the character being strong if the character's strength is greater than 12, and it should mention the character being very agile if the character's dexterity is greater than 13. So once we create this generate description method, so in order to do this, you're going to have to declare a new global variable. If I were you, I would make it of type string and name it description. And then we'll need to add to description as we go through and build that description within that generate description method. Once that generate description method is completed, you'll want to call the generate description method from the display character method that you've been using to produce a description of the character after displaying the character stats on the console window. Okay, well listen, I hope you enjoyed today's class. I hope that you weren't too offended by me getting tongue twisted and misstating a couple of things. I'll do better as we move forward. But the most important thing is that you learned something. And so until next time, this is Trisonius signing off.